start by recapping stuff we have seen last time. We can start with two nice problems. Okay, are we good? Everyone? Okay. Great. Awesome. So let us do some exercises from last time. So find points on the surface. Z equals okay, everyone. So let's start by looking at this function, at this surface, and I'm asking you to find the points where the tangent plane is horizontal. What does it mean the tangent plane is horizontal? Okay, so in the plane, whenever I have a tangent line and I say that the tangent line is horizontal, means that the slope is 0, right? Now in the plane, what is the slope really? What is the horizontal? So let's say this is the z-axis, right? The z-axis here, x and y are here. Is this plane horizontal? Is this plane horizontal? Is this plane horizontal? Okay, now what characterizes a horizontal plane? Vertical, normal, right? If a plane is horizontal, it means the normal to it is the vector k. We agree or not? Horizontal plane is equivalent to saying that its normal vector a normal vector is of the form is 0, 0, 1. Now, what is the normal vector to the surface at one point? We have seen that. At the point xy, what is the normal vector to the surface? Fx, yeah? Fx, Fy minus 1. We agree or not? At the point AB, at AB, the normal, well, AB and AB, the normal to the surface, or a normal to the surface, the normal vector to the surface is fxab, fyab, and minus 1. We agree or not? Yes or no? So what can I say about this? When is the tangent plane horizontal? Fxab is 0. Someone else also? Fyab is equal to 0. So what do I need to solve for the tangent plane to be horizontal? Fxab is equal to 0 and Fyab equals 0. Okay? Great. So let's find del z del x. It's 4x cubed minus, so who can help me? 4x cubed, yeah? Minus 4y cubed. And that's it, right? Del z del y is what? Minus 12xy squared, right? Plus 12y. So I need to solve these two equations simultaneously. You agree or not? Everybody agrees that if I have these two equal to 0, then my tangent plane is horizontal. Do we all see why or not? Do we see why? Okay, I mean, write down, if you want, write down the equation of the tangent plane. What is the equation of the tangent plane? It's fx AB times x minus a plus fy AB times fy AB times y minus b, and this is equal to z minus fab, right? This is the tangent plane. When is this plane horizontal? It's only when these two are 0. If and only if these two are 0, then you have a plane z equals fab. Okay? Is it clear? Linear algebra? Is that fine? Yes? Okay. So let's solve these two is equal to 0. So I need x cubed minus y cubed equals 0. This is I just cancelled 4. And then I'll just cancel 12. What do I need? Minus x plus y. Wait, what? Minus x y squared is equal to 0. Agree or not? I just cancelled 12 and I just cancelled the 4. Good or no? Great. So what does the first one tell me? X cubed is equal to y cubed. What does it imply? That x is equal to y. Let me put here. So the first one tells me that x is equal to y. Now I put in, let's see. So x is equal to y, which is the simplest. I mean, you can do either way, right? Because they're equal. So what do you get? You get minus x, y is equal to x squared, y is equal to x. So I put it here. Okay. Is equal to 0. So what do we have? We have x equal y and minus x squared plus x minus x cubed plus x is equal to 0. What is the solution of this one? How many solutions does it have? Factor an x out. So what do you get? Minus x cubed plus x. This is just x times minus x squared plus 1. This is just x times 1 minus x times 1 plus x. Okay? So what are the points at which the surface has a horizontal tangent plane? X is equal to 0 and
1.
so x equal to 0, what is the value of y?
0.
If x is equal to 0, then y is equal to 0.
X is equal to 1 and y is equal to 1.
Yeah, so let's just write this down here. So the surface has a horizontal tangent plane. So if x is equal to 0, what is y equal to? 0. What is z equal to? It's f of 0, 0. So, which is? What do? You plug in 0, right? 0, 0. What do you get? Minus 2. If x is equal to 1, what is y equal to?
1.
Everybody, do you see that? X equals to 1, y is equal to x, so y is equal to 1. And then what is the value of z? So it's 1 minus 4 plus 6 minus 2. So 1 minus 4 plus 6, so it's 2 minus 2, 0, which is 1, right? Yeah? Let's see. 6 minus 4 is 2. Minus 2 is 0, you get 1, right?
Yeah.
Yeah? If you plug in 1, 1, what do you get? Do you get 1 or not? Could you guess right? Okay. What's the other point? Minus 1. What is the value of y? Everybody? What is the value of y? Do we see y? Here? So let's plug that in. So let's see. x4, 1. I think it's the same, right? xy cubed, so it's minus 1 times minus 1. It's also 1, right? You see that? Okay? So this is going to be important, like in the next 2 lectures, solving the derivatives are equal to 0. Just in calculus 1, like in calculus 1, you have found like solving derivative is equal to 0, you found like some local maxima or absolute maxima depending on the case, and you had a second derivative test. So this will also translate to multivariable calculus. Okay? Any questions? Did I mess up something?
I have a question. Is the first one the answer or all through the...
Pardon me?
Is the first one, like the first vector, the answer?
It's a point, right? 0, 0, minus 2. 1, 1, 1. Minus 1, minus 1, minus 1. So you have 3 points at which the plane is horizontal. The tangent plane is horizontal. Is that clear? 100%? Is this stuff clear? Any questions on this? Yes, sir. One, yeah. So plug in minus one here on that when you get 1. Okay, great. Awesome. So is this question clear or not? Are we good here? Okay, so well, continue with the examples of the chain rule. So okay, by the way, did you see we saw implicit differentiation in calculus 1, right? Okay, great, awesome. Today we'll pick up with tomorrow we'll continue with this. Well, today we'll start with this. Okay, let's do this. Great. Okay, should we do more examples on the chain rule, or that's fine? Do you want to do more examples on the chain rule? A bit harder examples. Okay, so let's do some of them. I'll pick them from the book actually. Okay, so this one is a very hard one actually. It's a hard one. Okay, well let's do it. Let z be equal to xy, and x is equal to r cos theta. Guys, please, r sin theta. Okay? Show that. Man, this is gonna be tough. Show that. Well, it's not that tough, but show that del z del x squared plus del z del y squared is equal to del z del r squared plus 1 over r squared del z del theta. Okay, this is going to be a bit dull, but let's do it. Okay, great. So del z del r. Who wants to help? Who wants to help us find del z del r? Do you want me to draw the diagram? Should I draw the diagram? If it helps you. So you have z. Z is a function of what? X and y. Very good. X and y are themselves a function of what? R and theta. Very good. So, what is del z del r? Who wants to help? Who volunteers? Del z del r is equal to what? Please raise your hand. Yes, sir?
Del z del x.
Yeah?
Del x del r.
Del z del x. Del x del r.
Plus del z del y.
Del z del y.
Del y del r.
Del y. Oh, that's actually del z. This is going to be a bit easy. Now, what is del x del r? Who can help me? Del x del r? Please raise your hand. Del x del r. Del x del r is equal to what? This should be easy, right? What is del x del r? Yes, sir.
Differentiating with respect to r, so just cosine theta.
Exactly. Del x del r is cos theta. And what is del z del y del r?
Sine theta.
Sin theta. Very good. Thank you. Okay. So this is cos theta. A little easier than expected. Okay. Great. Let's keep this here. Okay, now the problem, where am I going to write? Okay, now what do I need else? What else do I need? Delta, yeah? Delta, delta, theta, yeah? Could you please help me how to find this? Delta, del x, del theta, plus. Okay, so could you please continue? And you, if you wish to continue, or someone else, do you want to continue? Oh, you're right. It's better to put it this way. Negative r sine theta delta del x. Yes. Plus r cos theta. Awesome. Now really, what do I have to do if I want to show the equality? I just have to what is easier, to go from this one to this one, or from this one to this one? To go from here to here is easier, right? Because I already have these expressions. We see that? We see that or not? Yeah? Everyone? Okay, so what is del z del r squared? This is just a plus b squared, right? Everyone? Yeah?
Yeah.
So what is that? This is just cos squared theta del z del x squared plus sine squared theta del z del y squared plus 2 cos theta sine theta times del z del x sine del z del y. Well, this is times, okay? Okay, now what is del z del theta squared? Or 1 over r squared del z del theta squared? I have 1 over r squared, right? Square this, r squared cos squared del z del y squared. Yeah. Well, let me put it this way. Let me start here. R squared sine squared theta del z del x squared plus r squared sine cos squared del z del y squared minus 2r squared sine theta cos theta del z del x del z del y. Right? Now what happens with the r squared? I'll write it. Okay. What happens with the r squared on this side? What can I do with the r squared? All of them. I can factor them. I can factor an r squared and then cancel it. So let me write this down. Del z del r is cos squared del z del x squared, right? Plus sine squared del z del y squared plus 2 sine theta cos theta del z del y times del z del we see where this is going when I add them up? Everybody? Plus or minus 2 sine theta plus theta del z del y del z del x. Do we see where this is going? Now when I add them up, what happens? Let's add them up. Oh, this is squared here, sorry. Squared, right? Let's add them up. Del z del r squared plus 1 over r squared del z del theta squared is equal to what? So what is the coefficient of del z del x squared? I combine the terms in del z del x squared. What do I get? Cos squared theta plus sine squared theta del z del x squared. Then what do I have? What is the term in del z del y squared? It's sine squared plus cos squared. Now what happens to these two terms? They cancel out. So what do you have here? Cos squared plus sine squared is equal to 1. Okay? Are we good? We good? Okay. Now I didn't define the second derivative in terms of del, right? I didn't write this. Did I ever write del squared? No, okay, I didn't write that. So, I mean, we'll do it later. Now we're going to move to implicit differentiation. I mean, is that clear or not? Is that clear? Let's do one more in the chain rule. And two variables. Can I erase it? May I erase it, everyone? 1 minute? Okay, well, I'll start writing here. Just to be sure I don't mess it up. We can write so it's a very nice program. Okay. Suppose I wrote the definition of fxx, right? I used this before. Did I use this before? fxx, did I use this? No. I never used that? I think I did the very first time we differentiated. But anyways, to my memory, maybe I'm mistaken. But so what is fxx? So what is fx really? Fx is just a derivative with respect to x. What is fxx? xxx? The second derivative with respect to x, basically. Differentiate with respect to x, y. And what is fyy? With respect to y process. Okay? Now the problem is that fyx and fxy. Okay? We have seen in many cases that these two are equal. We've seen this by example. Now, I think we will, maybe I'll give you examples where these two are not equal. I mean, pick any function, any nice function that you have, polynomial, differentiate first with respect to y, and differentiate your answer with respect to x. Then, differentiate first with respect to x, and then differentiate your answer with respect to y. You will get the same answer. Anyways, this is just for notation. And how do I write this? So, this is called del squared del x squared for fxx. And for fxy, it's called del squared del y squared. It's just a notation. Okay, just a simple notation. Nothing too complicated. Okay, great. Let's forget about this. It's just a notation, and then we'll move on to implicit differentiation. Okay, I mean these are just some notations that we're going to use afterwards. Now we'll move on to implicit differentiation. So I think next week I think we'll start a totally new chapter. Okay, we'll start with integration. This week we'll finish all the multivariable. Yes, sir.
Over del x del y. You do that's last.
Okay, that's so fyx, right? This is okay.
Yeah.
So this is just del squared x. Okay. But anyway, so we will not worry too much about this. I mean, maybe we will. But I mean, in this course, we can assume that y and x are switched order of differentiation. We will assume most of the time that we do. Tomorrow we'll focus more on this. Okay? Great. So let's go back to calc 1. Implicit differentiation. So usually there is something that you call an implicit function theorem. Now it's part of the curriculum of 262, but sometimes they don't do it in 262. But this year we're gonna do it. So we're gonna do it in full, actually. Usually they do the first two versions that we're gonna do today, and maybe tomorrow or after tomorrow, once you're comfortable with partial derivatives, we'll do the full version. Okay? So you have to know very well matrices, determinants, and things like that. Okay? Great. Anyway. So, in calc 1, let's go back to calc 1. You start with x squared plus y squared is equal to 1. What does this represent? A circle. Now, on the entire circle, is y a function of x? Can you say that y is a function of x on the circle? So the entire circle is something like that. Right? Is y a function of x here? On the entire circle? No, because it fails the vertical line test. Agree or not? Now, if you restrict to y positive, is y a function of x? What did you say? This part is y is equal to square root 1 minus x squared, and this part is equal to y minus square root 1 minus x squared. Do you remember this? Now, did that stand in your way of differentiating with respect to x? It didn't. How did you do this? Y is a function of x, so y is a function of x. Okay, and y prime here will denote dy by dx. Okay? How do you differentiate this? You took the derivative of both sides with respect to x. Derivative of x squared with respect to x is 2x. Derivative of y squared with respect to x, what is that? Is 2y y prime is equal to 0. You remember this? Yeah. What is y prime equal to? So y prime is minus 2x over 2y minus x over y. Okay, of course you need y to be different. Agreed? You remember this? Great. Now, in Calc 3, we write this as fxy is equal to 0. Now, what is fxy in that case? Everyone? If I want to write x squared plus y squared is equal to 1 as fxy equal to 0, what is fxy? Where fxy is, and you can still see the equal 1, but I prefer to have it equal to 0. Agree or not? Do we agree so far? Yes or no? Is there anything wrong with this? I just put the minus 1, so x squared plus y squared is equal to 1. Bring the 1 to the other side, and what do you get? fxy is equal to 0, where fxy is x squared plus y squared minus 1 is equal to 0. You agree or not? Yes or no? Easy. Great. Now, y is a function of x, so I can see this fxy as a function of x. Okay? So far so good. How do I differentiate this? Y is a function of x. X is a function of x. How do I differentiate this with respect to x? It's the very one chain rule that we have seen. Derivative of x with respect to x, what is that equal to? So it's dx by dx times f1 xy. Agreed? Plus, what is the second term? dy by dx times f2 xy. Is equal to, I differentiate the other side. What is it equal to? 0. What is dx by dx? 1. So what is f1 xy plus dy by dx f2 xy is equal to 0. What is dy by dx? How do I solve dy by dx? How do I solve dy by dx? I put the minus f1 on the other side and I divide by f2, right? Yes or no?
Yes.
Yeah? So dy by dx okay, now we will not worry too much about the conditions. We will worry about them maybe tomorrow. Okay? When we do the full function theorem, we'll worry about the conditions. Is that clear? Does that make sense? Everybody, does that make sense? 100%. Yes? Y is a function of x. What is this with respect to x? X prime, what's the derivative of x with respect to x? 1 times the derivative of f with respect to the first argument applied at xy plus y prime times the derivative of f with respect to the second argument at xy is equal to 0. And then I solve for 3y by dx. Now let's convince ourselves here. Let's convince ourselves and apply this here. What is, if fxy is x squared plus y squared minus 1, what is f1x y? f1x y is equal to what? Everyone? 2x, right? And f2xy is equal to what? 2y. This theorem tells me that dy by dx is equal to what? That is minus 2x divided by 2 2y, which is minus x over y. What answer did I get here? Minus x over y. Okay, now of course there are conditions for this on the partial derivatives. For now we will not worry about them. Tomorrow when we give the general version, with matrices maybe, invertible, non-zero determinant, something like that. Does that ring a bell? Invertible, non-zero determinant. So we will give a more general version of this. But I mean, what's one easy condition? That at the point, so say I need y to be different than 0. That's one easy condition, right? An obvious condition is that you need y to be different than 0. And I mean, if y is equal to 0, what can you say about the tangent here? It's a vertical tangent. And can you differentiate this function if y is equal to 0? So y is equal to 0 means x is equal to 1 or minus 1. Can you differentiate this function at 1 or minus 1? No, right? This function has no derivative at 1 or minus 1. Right? Okay, great. So your entire Calc 2, your entire Calc 1, there's a chapter called Implicit Differentiation, right? A big chapter called Implicit Differentiation. This big chapter can be, summed up by this formula. You remember you had big equations and you derived them with respect to x and you derived them with respect to x, but all you were doing is to change rules in two variables, and you did not know that. Okay? Let's do this. Let's do some examples. Find dy by dx. Let's pick an example from the book. Y cos x is equal to what? To x squared plus y squared. Do you want us to do it the Calc 1 way and then do it the Calc 3 way? Should we do that and see we get the same answer? Yeah? Let's do it. Okay, let's differentiate this with respect to x. Let's do it the Calc 1 way. We differentiate this with respect to x. Let's see if I got this right actually. Yeah. Differentiate this with respect to x. What do you get? Y prime cos x minus y sin x is equal to what? 2x plus 2y prime. Now what do? You bring the y prime together, right? That's what you did. So what is y prime? Y prime, what's the coefficient of y prime? It's cos x minus 2y is equal to 2x plus y sin x. Agree or not? Yeah? So what is y prime? It's 2x plus y sin x over what? Cos x minus 2y. Great. Now in Calc 3, let's do it the Calc 3 way. How do we do this? How do I start by writing this? What's one way? How do I start? By putting all the terms on one side. So I can write it as fxy is equal to 0. What is fxy? Sure. X squared plus y squared minus y plus x is equal to, this is fxy. What does this formula tell me? I mean, you don't have to memorize the formula. You can just derive it every time. Okay? Unless you want the formula. Do you prefer to use the formula? Do you prefer to memorize the formula? Sure. I mean, I don't expect you to memorize it. So, but if you want to memorize it, you can use it without justifying. Okay? But I will rederive it every time. Unless you want me to use the formula immediately. Should I use the formula immediately?
Can you rederive?
I rederive every time? It's better?
Just now.
Oh, it's down. Okay, sure. So I have fxy is equal to 0. and you want y as a function of x. Agree or not? Differentiate this with respect to x. What do you get here? So the first one is, let's do it with respect to x first, then plug them in, okay? Derivative of x with respect to x, what is that? 1, so it's dx by dx times f1 at xy, agree or not? Plus the derivative of y with respect to x times what? f2 at xy is equal to 0. So let me write this. Dx by dx is what? Derivative of x with respect to x is 1. So what is dy by dx? What is that equal to? It's minus f1 over f2. Both of them at x1. What is f1 with respect? What is the derivative of f with respect to the first argument? 2x, right? Plus y sine x. Oh, wait a minute. This is this term. You see that? It's minus 2x plus y sine x. Now, what is f2? xy. Derivative of f with respect to the second argument. 2y minus cos x. This one is here. You have a minus here. Okay? Those two are equal. You guys see this? So what did you do usually? You differentiate with respect to y, with respect to x, while y is a function of x. What is the next step? What did you do afterwards? You regrouped all the terms that contain y prime. All the terms that contain y prime is that 2xy. This is what we did before, without the limit. Okay? Is it clear? Yeah?
I thought you would only do like that part of the same rule, like x is a function of like f and d.
No, y is a function of x, right?
Okay, and for the dx over dx, you still have to do it like, even though x isn't a function of like r and f, for example.
No, so y is a function of x here only.
Yeah.
Right? We're assuming that y is a function of x.
That's why you have to do the whole same rule.
So if y is a function of x, right? Okay?
Yeah.
This is g of x, right?
Yeah.
What is g prime of x?
f1 of
f1, so what is g prime of x? This is just f1 x y of x, right?
yeah.
Plus y prime f2 x y of x. Okay?
Yeah.
Is that clear?
Yeah.
Everybody, is that clear? Yeah? Is that clear? Any questions? Clear? Clear? Yes or no? Okay. Let's do some more examples, and then we move on to two variables. Okay, now we will not worry about the conditions. We will worry about the conditions maybe tomorrow. We will worry about the conditions tomorrow. I mean, those of you who are taking 264, I think you'll revisit this, okay? So, 264 does, in 264 you will see the implicit function theorem. Here, we will do it in this course. I mean, it's part of the curriculum. It's done usually. Sometimes it's done, sometimes it's not. We'll just do it. Anyway, so let's pick another example. Find dy by dx if what? Let's pick a nice example. If cos xy is 1 plus sine 1. Okay, great. So how do we do this? Do you want to use the formula? Let's use the formula. I hope I memorized this. So what is it? It's minus f1 over f2. No? Yep. It's minus f1 over f2. Okay, great. What is dy by dx? So first of all, let's write this in the form fxy is equal to 0. What is this fxy here? Who wants to help? Fxy is equal to what? Yes, sir?
1 plus sine y minus cos y.
Thank you very much. Where fxy is equal to what? 1 plus sine y minus cos xy. Very good. So what is dy by dx? It's minus f1 at xy divided by f2 at xy. So what is f1 at xy? Derivative of f with respect to the first argument. What is it? So differentiate this with respect to the first argument. 0. What do you get? So you get y sine xy, right? Yes or no? Yes. You get minus y sine xy over what? The derivative of f with respect to the second argument. So you get cos y minus or plus, well, whatever, minus what's the derivative of cos? Minus sine, so you have to take an x into account, right? So xy derivative with respect to y is x minus minus x sine xy y sine x, so minus here, divided by cos y plus x sine y. Okay? Is that good? Did I put the minus in it? Are we good? Yeah. So Calc 1, the chapter of Calc 1, you know, that took like 2 hours, called Implicit Differentiation, is summed up here. Did I mess up a derivative or not? Yeah? Sin xy? Yes. Thanks. Okay. Great. Where? On top. Oh. I wrote it here but not here. Thank you. Okay. We do one more or is it enough? It's enough? Okay. One more? One more? Okay. If you want to know the formula, then you can use the formula. Right, so let's just be clear that I will ask you on the exam for the conditions for this suppose, okay? So tomorrow we will see the conditions on that. When does this hold? If I put a question on this that is not a multiple choice, I may ask you, state the implicit function theorem and use it to find I don't know what, okay? Let's do one more. So do you want a complicated one, complicated derivatives, or so let's see. Find dy by dx if arc tan x squared y is guys is equal to what? To x plus xy squared. Okay, great. What's the first step? Do you want to use the formula? It's better to use the formula. Do you want to use it immediately? Like, it's better to write it down and then redrive it, but if you want to use the formula immediately, that's fine by me. Great. What's the first step? Find dy by dx here. What's the first step? Bring everything on the same side, right? This is fxy is equal to 0. What is fxy? What is fxy? There are many possibilities, but what is it? What is fxy? X plus xy squared minus r10 x squared y. What is dy by dx? Who wants to help someone else? Dy by dx is equal to what? Do you want to rederive it or just apply the formula? Just apply. What is dy by dx? Minus f1 xy over 2 xy. What is minus f1 xy? What is f1 xy here? Well, let's do it here immediately. What is f1 xy? It's 1 plus y squared, right? Guys, please, 1 plus y squared minus 2yx, right? 2yx, 1 over. It's a bit ugly. Okay. Let's put a minus here. Divided by what? f2xy, so I get x at 2yx, right? 2yx here. Minus x squared over 1 plus x squared. Is that right? Did I mess it up? I don't think so. Did I miswrite something? This one. Okay? Is that clear? Great. Now let's move on to 3 variables. I have x and y, and I have x, y, and z. And let's suppose that z is a function of x and y. So I have partial derivative here. Here you had a single derivative, dy by dx. Now we will discuss when you have a partial derivative. Z as a function of x and y. Tomorrow we'll go to tomorrow or Thursday, I don't know, depending on the time we have. We will go on many variables. Okay? We will choose 4 variables, and you want to express 2 of them in terms of the other 2 things. How do we do this? Okay? Here, matrices will be involved. Okay, now let's start with a nice drawing. If I have x squared plus y squared plus z squared is equal to 1, what is this curve? What is this surface, sorry? It's a sphere. You see that? So any point that satisfies this equation, what is its distance from 0? 1. Right? You see that? You guys see this? Any point that that satisfies this equation is 1 unit of distance away from the origin. You guys see this or not? Because what is the distance from the origin? It's the square root of x squared plus y squared plus z squared. You see this? The distance from a point x, y, z to the origin is the square root of x squared plus y squared plus z squared. You've seen this, right? Yeah? So if I calculate x squared plus y squared plus z squared is equal to 1, all the points on this surface lie within or at exactly at distance 1 from the origin. So this is the origin, and I have a sphere, right? Well, that's not a sphere, but more like an axis. That axis. Anyways, I mean that's not very too much about the drawing. But what I care about, y, let's say this is x, This is y, and this is x. Or let's put y this way. I don't know why. Or put it this way. But anyway, it doesn't matter. Okay, now can you solve for z in terms of x and y in general? What is z? So z is square root of 1 minus x squared plus y squared. Is that true or not? Or it depends on the sign of z? Sure. So you cannot really solve. Does that define z as a function of x and y or not? Does that define z as a function of x and y? No, because technically no, because z at this point, so take x equal 1 and y is equal to 0, say. What are the possible values of z here? If x is equal to 1, well, that's not that, that's x is equal to 0, y is equal to 0. What are the possible values of z? So z is equal to 1, or z is equal to minus 1. So does this define a function of x and y? Technically, this doesn't define a function, because it depends on whether z is positive or z is negative. If z is positive, can you solve for z? If I tell you that z is positive, can you solve for z? What is it? No, okay, yeah. In general, if z is positive here, how do you solve this? It's square root of 1 minus x squared plus y squared. If z is negative, how do you solve it? Negative square root 1 minus x squared plus y squared. So here we have the same phenomenon here, right? Where z is defined implicitly in terms of x and y. Great. Now, z is a function of x and y. So z, suppose that so x and y are two independent variables, and z is a function of x and y. I tell you I want to find del z del x. I want to differentiate everything with respect to x. How do you do this? Again, x and y are two independent variables. Okay? They're not related to each other. Well, we accept by this thing. But y is not a function of x. Here. How do you find del z del x? What do you do? I differentiate with respect to, yeah? X. Let's differentiate with respect to x. What's the derivative of x squared with respect to x? 2x. Or del x in two sides, say. Okay, what's the derivative of x squared with respect to x? 2x. Y squared with respect to x. Y and x are independent variables. Y is not a function of x, it is 0. Great. What is the derivative of z squared with respect to x? If x is a function of z. If z is a function of x and y. It's 2z. Z prime. What is the z prime here technically? It's del z. Del x. Very good. What is that equal to? 0. Okay, this is 2 and del. This is del, so let's put 2 here. Okay? What is del z del x? Can you solve for del z del x? Minus x over z. Now what is del z del y? Minus minus y over z. Right. Let's differentiate this with respect to y. What's the derivative of x squared with respect to y? 0. Derivative of y squared with respect to y? 2y. Derivative of z squared with respect to y? Z is a function of x and y. So what is that? Yeah. 2z del z del y. Very good. I solve for del z del y. What do I obtain? del z del y will be equal to minus y over z. Is that clear? Is it clear? Is it clear or no? Yes? Okay, great. Let's now solve this. Let's now look at this and solve this. Before we do the formula, well, I mean, I really don't like the formula makes it easy, sure, but if you mess it up, you mess it up, right? So let's try to do it with should we do it without a formula first and see how things go, and then do a formula if you wish? Okay? I usually don't get it, but you know. Anyways, it's let's do an easy one. Find del z del x and del z del y. Ez is equal to xy. How do we start? How do we do this? First, how do we do this? I want to differentiate with respect to, what's the first one? X. Let's take del x on both sides. What is del x of e to the z? E to the z, del x, right? Derivative of e of something, the derivative of that something, times e of this, right? Yes or no? So the first side is del z del x, e to the z. Now, how do I differentiate del with respect to x? What is this? What rule should I be using here? Is x a function of x? Yes. Is y a function of x? So it's a constant, I can take it out. Is z a function of x? Yes. So here I should pay attention, it's the product rule. Very good. So I take the y outside. So I have to differentiate xz with respect to x times z with respect to x, right? Let me write it here. Okay, so what is this? It's just del z del x ez. And then I have y del x. Differentiate xz with respect to x. Who wants to help? Someone raise their hand if you wish to help. Who volunteers? Who volunteers? Differentiate this thing with respect to x. Nobody?
I don't understand this.
Y is the y outside?
Yeah.
You have a product, x, y, z. Is x a function of x? Does z depend on x? Does y depend on x? So you treat it as x? Exactly. You take it outside. Who volunteers? Someone else. Someone who hasn't spoken today. Imagine do it this way. Yes. It is. So z is one way. So you have z. So derivative of x times z. Very good. Plus x del z over del. Thank you very much. So what do you do now? You bring the del z del x on one side. So you have ez minus del z del x. What? Yeah, is that good? Yeah, it is. No, what? What am I saying? E to the z minus x del z del x. Yeah, well, I messed up, I guess. I have a y here, right? Minus yx is equal to yz, right? So del z del x to what? yz over e to z minus yx. Did I mess it up? Yx, yz, that's fine. That's okay, let's find del z del y. Let's find del z del y. What is del z del y? How do I do this? I take this equation, and what do I differentiate with respect to y? Very good. So del del y e to the z is equal to what? Del del y x y z. Great. Who volunteers for the first part? Want someone to volunteer for the first part, please? Del z del y times e to the z, awesome. Another person, preferably who hasn't said anything today, to volunteer for the second one. You said something to it. Yes. Someone else? Someone who hasn't said anything today. Please raise your hands. No? Yes? Exactly. So I take x out, so I have x. So yeah, the product rule, what does it tell me? Z plus. Awesome, thank you very much. Boop. So e to the z minus y x del z del y is equal to xz, so del z del y is equal to what? To xz over e to the z minus y. Okay, great. Are we good? Let's do the formula. Should we do a formula for this? Let's try a formula for that. I mean, you know, it's not really a formula. I mean, it's just a chain rule, okay? It's just a chain rule. So I have f(x, y, z) is equal to 0. This is how I start. In two variables, we have a surface, f(x, y) is equal to 0. And here we have f(x, y, z) is equal to 0. Z is a function of what? Of x and y. So I have really f here, right? F is a function of x, y, and z. Agree or not? X is a function of what? X only. Y is a function of what? Y only. Oops. Z is a function of? Okay? Now this is a bit tricky, right? This is a bit tricky, but the notation is bad. But let's assume that you can change here. It says S, 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 T. Sorry, S, T, S, T. Okay? You just take an x is equal to S and y is equal to T. Doesn't matter. Anyway, how does that differentiate this with respect to the chain rule? So if I want to differentiate with respect to x, what do I get? Right? That's what I get. Agree or not? I differentiate both sides with respect to x. You see that? With respect to x, how do I differentiate this? So this is df by dx, or how did we denote this? f(1), right? Derivative of f with respect to the first argument. Agree? What is dx by dx? Dx by dx here is 1. What is dy by dy? Is 1. Okay? I mean, you can still put an xy here, but the other branch will be 0. Okay? Is that clear? Great. Now, how to differentiate it with respect to x? Who wants to help? So what do I need to find? I need to find all the paths all the passes that go away, that end in x. How many paths that end in x do I have? 2. What is the first one? Here. And the second one is here. Right? Great. How do I do this? What is the derivative of this with respect to x? Who can help? We look at the path and sum them up. Right? How do I do that? Please raise your hand if you wish to answer. Yes?
This is the derivative of x times the derivative of the whole function with respect to x.
Exactly. With respect to the first argument, yeah, very good. What's the derivative of x with respect to x? 1. Very good. 1. F1 x1 z plus
The derivative of z
the derivative of z with respect to x times
the function of the basic function.
with respect to the third. Is that clear? Here should be del x. I mean, should be del x. Okay, sorry. Del y, del y. Are we good here or not? Is that clear?
Yes.
Everybody, is that clear? Yes, sir.
Is it fully up to you to say z as a function of x and y or x as a function of y?
So here, yeah, so the notation when you do in several variables will be more complex, and it will tell you which variable to consider as a function of two others. Okay, so here we're just assuming z is defined implicitly as a function of x and y. Okay?
So when you take f3,
Yeah.
what are we going to do?
So f3 is the derivative of f with respect to the third argument. Really, so z is not, when you take f3, is with respect to the third argument.
Yeah.
So z with respect to z only, and not considered as a function of x and y. Okay, is that clear? This is why I don't like the del notation. This is more clear to me. f3 is a function, and you can apply it to a point. Okay, is that clear? So what is del z del x? Is minus f1 over f3 x1. So from the context it will be clear what I consider as, I mean, it's on Thursday everything will be hopefully clear. And the general function, the general statement is much harder than this. Okay, this is a very particular case. The general statement is, so what you might have two variables with respect to two variables, say. Anyways, let's not worry about this. Okay, we will see this on Thursday. So we will see, like, for example, what's the derivative of two functions, say, with respect to two variables. Things like that. We will put them in a matrix and call it the Jacobian. And take the determinant of the matrix. Okay? Very nice. Very, very nice theory. Linear algebra. Works out very well. Anyways. What is del z del y? Anyone can help? In the same way. Del z del y, what is that? Who wants to help with del z del y? I take the derivative of x, y, z with respect to y. What is del z del y? Very good, thank you very much. So that's 2x, y, z plus del z del y times f3 x, y, z is equal to 0. So del z del y is equal to what? Minus f2 x, y, z over f3 x, y, z. Okay, let's do some examples. You notice that the pace drops significantly than before, right? It's way slower, is it? Yeah. That's what I noticed. Okay, that's good. Yeah. So it's gonna be way slower until like tomorrow, and after tomorrow it's gonna go up again. And then Tuesday we'll start slow and then go very fast. Okay? Because you should be comfortable with this stuff by now. Okay? Great. Anyways. I think we're way ahead in the program. But yeah, we're way ahead. So I think I have two classes to fill. This is how I count it. So let's see how we do this. I think, yeah. So let's do some examples. Find del z del x. Find del z del x. And del z del y. Y z plus x on y. Okay, folks, let's focus on this. How do we do this? How do we start by doing this? We can differentiate with respect to x and then differentiate with respect to y. That's fine. But if you want to use the formula, let's try to use the formula. What? Oh, okay, everybody, great. So how do we use the formula? How do I start first? How do I start first? Yes, sir. Is equal to 0. Very good. So what is f(x, y, z)? Okay. What is f(1, x, y, z)? So what I need del z del x. Very good. Thank you. What is del z del x? You want to go ahead?
Minus f1 x y z over
Awesome, thank you very much. So what is f1 x, y, z? What is f1 x, y, z? f1 x, y, z, what is that? f1 is with respect to the first argument, so with respect to x.
We have to partial derivative of z squared.
No, so because here you're just taking it with respect to the first argument.
Minus y.
Awesome, thank you very much. And what is f3 x, y, z? Someone had their hand risen? No? Or someone wanted to have 2 x, y, z? You wanted to have 2? Who wanted to have 2 x, y, z?
2z minus y.
2 z minus y, very good. And what is f3 x, y, z? Who wants to volunteer for f3 x, y, z? You differentiate with respect to the third argument. Did I mess it up? Did I mess something up? f2 with respect to y? Oh no, what am I saying? It's just minus y, right? Minus y, minus x over y, right? f2 minus yz. Hold on, thank you. Thank you. What is f3 x, y, z? Differentiate with respect to z is 2z minus y. So del z del x is minus f1 over f3. What is minus f1? So it's ln y over 2z minus y, right? And what is del z del y? It is minus f2 over f3. What is that? What is minus f2? So it's minus z minus x over y, right? The differentiate with respect to y, it's 1 over y. So it's z plus x over y divided by what? 2z minus 1, right? So z squared minus yz. Yeah, 2z minus 1. Awesome. Are we good here? Are we good or not? Okay. Now, what time do we have left? How much time do we have? 1 hour. Great. That's an excellent. We're going to the next topic. Now, if I have a tangent, let's go back to class 1. You had a surface, or a curve, sorry, defined implicitly. Okay, so x squared plus y squared is equal to 1. You can find y prime, right? By implicit differentiation. And then if I give you an x, and I give you some restrictions on y, so for example, if I tell you, I have x squared plus y squared is equal to 1. I tell you that x is 0 and y is positive. What is the value of x and y? X is 0 and y is? If x is 0 and y is positive, y is 1. So you have the point 0, 1, and you can find y prime at that point. Do you agree or not? So what can you do? If you can find y prime at x equals 0, and y at x equals 0. If you have these two, what can you do? If you have y prime of 0 and you have y of 0, y of 0 between quotation marks, because you know y is not an explicit function of x. But in that case, y is, right? I mean, you know, if y is positive, if I tell you y is positive, then y is a function of x, right? Y is just root 1 minus x squared. So if I tell you y of 0 and y prime of 0, what can you do? What can you find? What's this? The equation of the tangent line. We agree or not? Yes or no? Now, if we have a surface defined implicitly, what can I find? Perhaps you have all the given data. Equation of the tangent plane. We see this or not? Yeah? Can you find del z del x at that point? Yeah? Can you find del z del y at that point? If I give you the point, what can you find? The tangent plane. Okay? So let's do this. There are many ways this can be done. Let's see if there are many other ways of doing it, but I think the book may not treat it this way. The book may not treat it this way. Let's see if I do it. Okay, let's do this now. Let's do this now. Okay, so an example. Suppose that x squared plus y squared plus z squared is equal to 1. Okay? And I tell you find the tangent plane to this sphere at 0, 0, 1. What do you expect the answer to be? I have a sphere, right? You have let's say a sphere, and 0, 0, 1 is the upper vertex, right? What do you expect the tangent plane to be? Horizontal, right? So what do you expect del z del x to be? Del z del x is 0. What do you expect del z del y to be? Yeah? Let's try this. So how do I find del z del x at that point? How do I find this?
You just compute delta delta and zero.
Sure, we can do that, but if you want to use the formula, how do I do that?
Negative F1.
Negative F1 over F3. What is F1 here?
2x.
F1 is 2x, right?
2z. Oh, no.
Negative F1 says 0, 0, 1, right? Over F3 as 0, 0, 1. Right? And what is fxy here? Fxy is sorry. This is just x squared plus y squared plus z squared minus 1. And I have that fxyz is equal to 0. What is f1? What is f1 of xyz? 2x, right? f1 of xyz is equal to 2x, right? What is f2 of xyz? 2y. What is f3 of xyz? 2z. So, minus f1 at 0, 0, 1, what is this? 0. And f3 at 0, 0, 1, what is that? 2. So it's 0 over 2, which is 0. And what is del z, del y at 0, 0, 1? What is that? Also 0, but let's write it this way, thank you. Minus f2, 0, 0, 1, divided by f3, 0, 0, 1, which is just 0 over 2, which is 0. Right or no? Are we good? Yes? Now, what is the equation of my tangent plane? I have the point, right? 0, 0, 1. And I have a normal vector. What is the normal vector? I have del z del x, I have del z del y at that point. What is my normal vector? 0, 0, 1, or minus 1. Right? What is it? What is the normal vector here? Well, in that case, both work, right? Because the first argument is 0. So what is the normal vector here? 0, 0, minus 1 is normal to the curve, but the point at the surface at 0, 0, 1. We agree or not? How do I find the tangent plane? Well, this is this, times x minus 1, times y, times x minus 0, y minus 0, and z minus 1 is equal to 0. We agree? This is how we find the tangent plane. Yes or no? We remember this? You have a normal vector and you have a point. What is the normal vector? 0, 0, minus 1. What's the point? 0, 0, 1. This is how we find the tangent plane. What's an equation of the tangent plane? So z is equal to 1. Yes, sir?
How did you get minus 1?
Where? Here? What is the point?
No, okay.
Here?
Yeah.
Del z del x, del z del y, and minus 1 is the normal vector. fx, fy, minus 1. Right? Del, you see that?
Yeah.
Del fx, fy, minus 1. fx, fy, minus 1. Are we good here? Are we good? Okay. Let's now look at it another way. Maybe we'll look at it another way. Let's try to find another way to reason here. Let's try to do it another way. It's going to be a bit, it's actually not going to be a bit difficult, but it's not going to be difficult. I mean, there's a reasoning with the same reasoning that you have done before, with parametrizing stuff. But let's try to, maybe not a very rigorous reasoning, but let's just replace. Okay? Replace stuff. Okay, so this is an example. Now, I want to try to find, is this clear? I mean, you can do things here this way. This is an easy way of doing things. Okay, let's do it this way. I mean, you know. If you like, we can do with a formula, or we can just do it this way. What do you prefer? Formula? You prefer with a formula? Sure. I mean, the formula is not much more difficult, but you know. Now suppose fxyz is equal to 0, define a surface. Okay? Now I want to point at this on the surface and x0, y0, z0, and well, you know, fx, y0, z0 is equal to 0. So basically, x0, y0, z0 belongs to this surface. Okay? Is that clear? If fx0, if x0, y0, z0, if f of this is equal to 0, this means that the point belongs to this surface. Agree or not? Yeah? If the coordinates of the point satisfy an equation, means that the point belongs to the surface defined with this, right? Yes or no? Okay. What is del z del x? Tangent plane. Of course, I will not mention all the derivatives. So f has all derivatives with respect to 1, 2, and 3, and we'll see on condition. The tangent plane to the surface defined by fxyz is equal to 0 at x0, y0, z0, which satisfies is given by can be derived using the following. So what do I need? I need del z by del x at x0, y0, z0. Is that right? That's what I need. I need del z del x at x0, y0, z0. Do I need this or not? What are the elements that I need? I need the normal, a normal vector, and a point. I have my point. What is my normal vector here? Del z del x at x0, y0, z0. What is that equal to? What is that equal to? Minus f1 at x0, y0, z0 divided by f3 x0, y0, z0. What is del z del y at x0, y0, z0? What is that? Minus f2 over f3. Agree or not? Everybody, you agree? Now, how do I find the tangent plane to this surface? What's the normal vector to my surface at the point x0, y0, z0? It's del z del x is at the point, del z del y at the point, and what as well? Minus 1. Right? So how do I find the equation, an equation of the tangent plane to my surface? An equation of the tangent plane is equal to what? N of the tangent plane to What is that equal to? Let's try. Let's write it here. X minus f1, x0, y0, z0, over f3 times x minus x0, right? Plus or minus f2, x0, x3 times y minus y0 minus z minus z0 is equal to 0. We agree or not? What is my normal here? It's this one, and minus 1. So far so good. The x component of my unit normal times x minus x0. The y component of my unit normal times y minus y0. Minus 1 times z minus y0. Is that clear? So far so good? Yeah? Are we good or not? Is it clear? Any questions? Any questions? Yes, sir.
Is the Z0 location there, is it the same as f of f0, y0, z0?
Well, it's the same one as in here, yes. So x0, y0, z0 is a point that satisfies this equation. Okay? So if you take x squared plus y squared plus 1, and we plus z squared is equal to 1, we took 0, 0, 1. Okay? Because 0 squared plus y squared plus z squared minus 1 is equal to 0. Okay, is that clear? Well, let's put it minus 1. Now, what do I do here? What can I do? Can I change my minus into plus? All the minuses, can I change them into plus? Yeah, I can change all the minuses into plus. And can I multiply everything by f3, x0, y0, z0? Multiply everything by minus f3, x0, y0, z0. What do you get? You get f1 times okay, provided this f3 is non-zero. Provided, and you need a bit more as well, but you may need a bit more. Anyways, for now, let's assume this one. Is that 0? No? Are we good or not? Yes? Yeah? What's up? Yes.
What's after the y squared?
What's after the y squared here?
Yeah.
Z squared minus 1 is equal to 0. Okay? Let's do an example. Should we do examples? Should we do examples using this? Yeah, let's do some examples. So the equation of the tangent plane of a surface defined by fx, y, z is equal to 0. You can just take f1, x0, y0, z0. f2, x0, y0, z0, and f3, x0, y0, z0 as your normal vector. Provided this f3 is non-zero. Okay? Oh, well. Well, I mean, yeah, to derive it this way. Let's do an example. Of course, under the same assumptions, what's the normal vector to the surface at x0, y0, z0? It's just f1, f2, f3 at x0, y0, z0. You agree or not? A normal vector to the surface. and f3. Okay? I think in 264 you will see more stuff of this. But let's do this. Let's do an example.
Is it easier to use the second equation?
Where? This one?
It's easier than the one above.
The one above?
Like which one should be used?
Whichever you want. All are equivalent. Okay? You can use all of them. Okay? All are equivalent. Okay, let's give an example. We just let me think of something nice. Let me think of something nice. What is that? Okay, let's think of something nice. I don't know if that's true actually. Okay, consider this here. Let's see if the book has some nice problem on this. If they do, then I will use them. Well, I don't know if it has, but let's. Oh, okay, yes, I have it. So, consider the figure x squared plus y squared plus z squared is equal to what? Show that the normal line to the sphere at a point A, B, C, where A squared plus B squared plus C squared is equal to 1, passes through the origin. Yes.
If we have like x equals some function of y,
Yeah.
and it's a plane, and
X is equal
sure.
at the surface, yeah.
And we want to find the tangent plane.
Yep.
Then it would be a bit weird to use the old formula because x equals. Something.
Sure. Yeah. So, but what you can do is that you can
So in
just
that case, we use this one.
yeah, you can use this one, or you can say that it's del x.
Yeah, I did. Yeah,
You can rearrange it. Yeah.
Okay.
Yeah. Okay. If you rearrange it, that's. I mean, here we derived it with we're assuming that is a function of x and y, right?
Is this a gradient thing?
Yeah. I mean, but we didn't see that yet. Okay. So we'll see this tomorrow. Okay. The word gradient, we'll see that tomorrow. Okay. So. Show that the normal line to the sphere at the point ABC, where a squared plus b squared equal 1, passes through the origin. Again, I told you on the final you may have a question like that. Okay? You may have a question like that. Something like that. Now, how to proceed on this function? How to proceed? How do we proceed? Now, is z a function of x and y? No, because you may have multi-values of z. So what's the best way to use? What's the normal to the curve at the point ABC? I have it here. Right? What is my surface here? What is my fx, y, z? So my sphere is fx, y, z is equal to 0, where fx, y, z is equal to what? Where Everybody agree? Now, what's the normal to my sphere at the point ABC that belongs to the sphere? What is the normal at this point? What is the normal at this point? What is the normal at this point? It's written just in front of you. F1, F2, F3, at ABC, right? So the unit normal, a normal vector. 2 at ABC is equal to, or is, F1 ABC, F2 ABC, and then F3 ABC. What is F1 ABC? What is F2 ABC? And what is F3 ABC? 2A, 2B, 2C. We're good? Are we good? It's 2A, 2B, 2C. Now, how do I show that the normal line, what's the normal line to the surface? It's the line that has the direction of the normal and passes through the point ABC. Passes through the origin. What's one way of doing it? There are many ways of doing it. But what's one way of doing it? There are many ways of doing it. So let's draw my sphere. Let's draw our sphere here. And I have ABC. Okay, let's pick ABC to be here instead. And I have the normal vector going in that case. Going in that direction. I have this normal line. Now, how do I show that this normal line passes through the origin? And you have a normal direction here. Okay? You have a normal, a normal vector. How do you show that the origin passes through that normal vector?
You do the parametric.
Sure, we can do that. So, a parametric equation. Parametric. A system of parametric equation to the normal line. ABC is, what is that? X is the point, the x value plus 2AT, right? Y is B plus 2BT, and Z is C plus 2CT, where T is an R. Now, how do I check if the origin belongs to this? I need to find a value of T that gives me 0, 0, 0. Isn't that right? What value of T does such value exist? What value of T will give you 0, 0, 0? Minus 1/2. If you plug in T equal minus 1/2, you get that 0, 0, 0 belongs to this line. Okay? Are we good? We've seen this before? Linear algebra, right? We've seen this? Have we seen this in linear algebra? Yeah? So if you have a parametric equation, a system of parametric equations defining a line, how do you check that a point belongs to a line? You need to have one value of the parameter giving you the point, right? So if T is equal to minus 1/2, we get that 0, 0, 0 belongs to the normal. Should we do one more like that? Let's do one more like that. If we have time, I think it's important to do something like that. But. Okay, let's do one more. Yes?
What would be another way to check the origin?
Oh, what's the other way? That's a good question. That's a good question. Take the vector from the origin to the point. Is that vector parallel to the normal vector? If it is, then the origin belongs. Okay? Is that clear? Okay, let's do one more. And how much time do we have left? 25 minutes. Okay, so we have time. This is also an interesting question, also from the book. Show that all the tangent planes this is in the book as well. This is from Stewart, by the way. To x squared plus y squared is equal to z squared. So that every plane, let's use the let's see something. Just a second. Show that the tangent plane at ABC, where is equal to 0. Where a squared plus b squared is equal to c squared, and ABC is different than 0, 0, 0, passes through okay. So I have a point on my surface. How do I find the tangent plane? I need a normal vector, right? Agree or not?
Yes.
How do I find, first of all, is this a surface where z is a function of x and y, or it's defined implicitly? Implicitly. So how do I write this? How can I write my surface? How can I write my surface? How can I write my surface? In terms of fx, y, z is equal to 0. What is my fx, y, z? Yes? Thank you. Is equal to 0, where z squared minus x squared. Okay? What's the normal vector to my surface at a point ABC? The normal to fxy z is equal to 0 at ABC. Of course, where fabc is 0. The normal vector. A normal vector, sorry. What is it? Who can help me? What do I need? Someone else? What do I need to take? The derivative of f with respect to 1, 2, and 3, the first, second, and third argument, applied at the point ABC, right? What is the unit normal in that case? What is the unit normal in that case? What is the normal in that case? What is f1 of x, y, z? f1 of x, y, z, what is that? Minus 2x. What is f2 of x, y, z? Minus 2y. So what's the unit normal to fx, y, z at the point ABC? Yeah, so someone say? Please raise your hand. So it's f1 ABC, f2 ABC, f3 ABC, right or no? Yeah? What is f1 ABC? Yes. What is that? What is f1 ABC? Minus 2a. What is f2? Minus 2b. And what is f3? Very good. So I have a normal vector and I have a point. Any questions on this? Is that clear? Is that clear? Yeah? Is that clear or not? Yes or no? Okay, now what is my point here? It's ABC. I want to check that this tangent plane passes through the origin. How do I check that? Pardon me? Okay, so you want to do a parametric equation of tangent plane. I mean, you can do that, but it might take some time, right? So let's try to avoid this. Yeah, so I find an equation of the tangent plane in terms of x, y, and z, and then I plug in 0, 0, 0 to see if it satisfies, and I check if the origin is satisfied. What's another way of doing it? What's another way of doing it? So I need to check the tangent plane goes through the origin. So the tangent plane goes through the origin. I know I have a point on the plane. What is the point on the plane? ABC. And I want to check that if the origin belongs to the tangent plane. So the origin belongs to the tangent plane if and only if this vector is normal to the normal vector. Have you seen this? No? Is that clear or not? Yeah? So if this vector is normal to the normal vector, then this point belongs to the tangent plane. Linear algebra belongs to the plane. Right? So you have a normal vector here. Okay? This vector is normal to what point? To what plane? The finger pointing down is normal to the table, right? Now, I have a point here, let's say. Let's say this is a point. Okay? Now, how can I check that another point belongs to this plane? If and only if, how do I check that this point belongs here? If this vector is normal to this vector, then it does belong. Now, does this point belong to this plane? No. In fact, are these two normal to each other? Are these two vectors perpendicular to each other? No. Is that clear or not? Or you prefer the regular way? The regular way, find the equation of the tangent plane and check if 0, 0 belongs there. 0, 0, 0 belongs there. Let's do that. An equation of the tangent plane is what is that? So this is just minus 2a, or well, what is that? It's 2a, or minus 2a, times x minus a, minus 2b, times x minus b, plus what? Plus 2c times z minus b. Okay? Now, do you want to simplify it first? Do you want to try and simplify it? You don't have to, but let's try to simplify it. By the way, so if a point belongs, a point the tangent plane if and only if the vector of that point and the point formed by this point and ABC is perpendicular to the normal. You can see that from here. This is why. Okay, but anyway, so do you want to try to simplify it? What can I cancel? I can cancel the minus 2 of it, right? So I get ax minus a plus b, y minus b plus or minus c z minus c is equal to 0. Let's do it. Ax plus by minus bz. What do you get here? Minus a squared minus b squared plus b squared is equal to 0. Now, what do I know about ABC? It belongs to the surface. So what is c squared minus a squared minus b squared? What is that? Look here. By hypothesis, what did I say about c squared? Is equal to a squared plus b squared, right? Look at the first line of the question. It says that c squared is equal to a squared plus b squared. So that I'm sure that this point belongs to the surface. So what do I get? I get ax plus by minus cz is equal to 0. Does the origin belong to this plane? Does 0, 0, 0 belong to this plane? Yeah, because when you plug in 0 here, 0 here, 0 here, what do you get? 0, okay? Since 0a plus 0b plus 0c is equal to 0, and 0 belongs. Okay, what time is it? How much do you have left? 15 minutes, okay. 16 minutes, thank you. Yeah. Okay, so
You would just do the dot product and then the theorem.
pardon me?
For the other way,
Yeah, so let's do the other way. We can do the other way. So I have minus 2a minus 2b. 2c is normal. Is a normal vector to the tangent plane. 2 z squared is equal to x squared plus y squared. At ABC. What do you need to check? You need to check if 0 belongs to that plane, if and only if ABC minus 0, 0 dot minus 2a minus 2b and 2c is equal to 0. Okay, is that clear, everyone? Is that clear? Is this clear? You have a normal vector to this plane. Okay? And I have a point on this plane. How do you check that another point belongs to this plane? If you take the vector in this plane, it should be normal to the normal vector. Yeah. So let's see. What do you get here? You get minus 2a squared, right? You get minus 2a squared minus 2b squared plus 2c squared, which is 2 minus a squared minus b squared plus c squared, which is, okay? This is easier. This is easier, but you just should be comfortable with vector geometry of it. Okay? So please expect a question like that on the final. You know, show that all the lines, all the normal lines, and things like that. Okay, this is not. This should not be very. It should not be very difficult, but at the same time, you know, yeah, you should think of it. Okay. Now we have 16 minutes. We have 16 minutes. Maybe I will state Clairaut's theorem. We have 30 minutes. I'll say Clairaut's theorem, so tomorrow we can maybe do an exercise or two. So tomorrow we can continue with this. So maybe I'll push the implicit function, the full version of the implicit function theorem until Thursday. Okay, so Thursday please review your linear algebra. Like determinants, review determinants, review bases, review what is invertible. So what is an n by n matrix invertible? If its determinant is non-zero. Awesome. Okay. And you know the determinant of 2 by 2 matrix? A, B, C, D. How do you compute that? A, D minus B, C, D. Okay? And let's see. For 3 by 3, do you know the determinant? Well, there's no formula. You just have to. Do you know how to do the determinant, a 3 by 3 determinant? Okay. Yeah, exactly. This, right? Or you can do it in other ways. But please review these. We may go. I think we will not go further than 2 by 2. Okay, but let's stay safe and. Okay, great. So let's. So how do you define it? So first of all, suppose f. Let f(x,y) be a function. Variables. Now, what is f(x,x,y)? Fx is, we denote it by del f, del x, right? Fy, what did we denote it by? Fy is del f, del y, right? Or we denote it by x. Okay? Now, fxx, what is that? It's just del x of fx. So you just put it this way. Okay, so fxx, we define it as fx, and then the second x comes here. So you differentiate with respect to x, fx. Okay? We denote this because, you know, it's we write this as del squared f, this is a notation, del x squared. Okay? The second derivative with respect to x, meaning you differentiate with respect to x once, and then with respect to x again, we denote it by this way. At the same time, the same way, what is f by y? How do we denote this? Yeah, so at the end is what you, so del del y, del y f, right? Which is del squared, del y squared. Now, fyx. So this is just by definition, we define it to be fy sub x, right? So what do you differentiate with respect to x? Fy, right? So it's just del x of fy. What is fy? It's del x del y. Okay. I think I don't know if the book uses this, but anyways. I think they do, yeah. What do they? So they do. Yeah, they do. What is this? It's just del squared x over del xy. Now, what is fxy? This is just a notation, okay? I think the very first lecture we did these two derivatives, didn't we? We did two derivatives, no? The very first lecture we did, yeah. Now, fxy, what is that equal to? It's just del squared x by del y del x. If you remember the very first lecture, unfortunately I think the recording was not available, but the very first lecture, when we talked about derivatives, we differentiated with x and y, and we saw that in many cases, It's the same. You remember this or not? Let's give an example. fxy x squared e to the y times x. What is fx xy? This is 2x times e of yx plus what? Plus, now you give it with respect to x squared times y, right? Exy. Agree or not? Yes or no? Now what differentiates it with respect to y? What do you get? So you get 2x squared eyx, right? Plus x squared times exy plus y x exy. Agreed? Now let's take fyxy. Fyxy, what is it? Just x cubed eyx. Agreed? I differentiate with respect to y. Now let's differentiate this with respect to x. F1 x. What do you get? You get 3x squared. Wait. So you get 3x squared. I made a mistake here? Yeah, I made a mistake. It's easy to find that I made a mistake. So fx 2x eyx plus, I differentiate with respect to x, so y x squared dxy, this is good. Let me differentiate with respect to y. So you get 2x, this is good, plus x squared, I differentiate with respect to y, it's 1 dxy, y, I differentiate with respect to y, so 2x eyx. I differentiate with respect to x, so the y goes down, and I keep it squared, dxy. This is good, right? Let's differentiate with respect to y. I bring the x down, and I keep the eyx, which is fine, plus I differentiate this one with respect to y. So the x squared stays, y is 1, dxy, plus I bring the x down, right? And I keep the y. This is good, no? Is this good? Is this good? Now let's see here. I differentiate with respect to y. What do I get? X cubed e to the yx. Now let me differentiate this with respect to x. So I get 3x squared e to the yx plus, how do I differentiate this with respect to x? X cubed. Let me differentiate e to the yx with respect to x. With respect to x, it's y e to the yx. Let's see what went wrong. So I have, no, that's right, right? 2x squared plus x squared dxy, 3x squared dxy, right? And x cubed y dxy is this, okay? What do you notice about these two? They're equal. Now this is not true that they're always the same, but in many nice cases, they are the same. So let's talk about Clairaut's theorem. Suppose f is defined, or how did they say it? Well, on a disk D, that contains the point A. If fx and fy are, fxy and fyx are continuous on D, then y, ab is equal to f1, x, ab. We say that the mixed partials are equal. Okay, how much time do we have left? 5 minutes? 3 minutes. Great. No, I think it's, I mean, sometimes we denote, let's do that. Let's write this notation and finish it. fxx usually can be denoted by f11, fyy. What is fyy? fyy is f22. fxy is what? f12. And fyx is f21. And at a point AB where f12 and f21 are continuous, if f is defined on a disk that contains the point AB, what can I say about f12 AB and f21 AB? They are equal. Okay? Great. So there are examples where they're not equal. I don't know if we'll worry too much about them, but maybe next time we can give an example. Great. So any questions? Any questions? No? Great.